Hi all, good day to everyone. So, welcome to my Deep Learning by First Principle series. My name is Rajagopal. In this video, we are going to see a Pytorch foundation, foundation logic. Okay, this is a simple one. Okay, everyone knows. Okay, recursion. Okay, recursion everyone knows. Okay, so why I choose this topic? Because the PyTorch, okay, the PyTorch, that foundation of PyTorch is nothing but that is recursively, okay, what I say, the final object, okay, whatever the final object recursively has the information of all its child nodes. Okay, that way, because the child nodes are nothing but the neural network nodes. If you see, okay, this is my sample list. Okay, if you see, this is the one list. Okay, this is one complete list. Okay, so this list contain this list. Okay, this list. Okay, so and this list contain this list. Okay, so and this is the one, this list contain this list, and then this list contain this list. Okay, so this way this list is nested with various list. Okay, various list. Okay, if you see if you see our neural network, okay, same analog to our neural network. Okay, neural network, neural network, um, if you see, this is our output. Okay, this is our output. Okay, this is our hidden layer. Okay, this is our another hidden layer. Okay, okay, this is our input layer. Okay, so this is our input layer. So if you get information this way, okay, this way this is fully connected. Okay, so this way you will get, okay, this way this will operate. Now whenever we will get the output here contains the effect of all these calculations. Okay, so if you combine all these things only, we will get the result here. Okay, so it contains, actually the meaning is it contains all these calculations. Okay, so in such a way, in PyTorch, okay, in PyTorch, okay, in PyTorch, the last node, okay, the last node object contains all the information of these previous nodes and all these previous calculation. Okay, so this way, okay, this way the PyTorch, okay, this way the PyTorch is running. Okay, so for this purpose, okay, we have to understand. So whenever we are applying back propagation and each and everything, it is recursive and it is recursively obtain all these nodes. Okay, all these nodes backwards. Okay, in this way. So we have to flatten. Okay, if you want to know the weight of this, we have to know all this. Okay, now the values are flattened. We have to calculate this one, we have to calculate next one, we have to calculate next one, we have to calculate this one. Okay, so this way we have to know this is the nested thing. Okay, it is stored in the nested thing. If you want to do a back propagation, you want to the in a serious way of all these things. Okay, one by one we need it, yeah, serious way, or that's a simply a flattened way. Okay, the flattened way. So we have to know. So if you want to use the PyTorch, okay, so we must understand and we must know this recursive logic. Okay, so most of you know this recursive logic. Okay, so anyhow, for remembering the logic, you will use this video. Okay, if you don't know really, so you have to take a note. Okay, and you will try a different, okay, different way to solve this recursive algorithm. Okay, so first, okay, so this way. Okay, now I I I I took a simple list example. Okay, I took a simple list example here. Suppose, okay, suppose this is our this way. This is the object. Okay, so if it is so this is the output. Okay, this is the this output layer. Okay, this is this output layer. This output layer contains all this information of all this. Okay, this is also list. Okay, list contains list, list contains list. So like that, this is the output node. Output node contains all the information of the previous. Okay, these previous two nodes information, and then these nodes contains all the information about the the before nodes, all the information about that the the previous one. Okay, previous one behind this node. Okay, so this way this nested loop is okay. This way this nested loop is formed. Okay, next we will see. Next we will see. So this is our okay, whatever we have. So this is our nested loop. Okay, this is our nested loop. Okay, this, so now we need to, so if you want to, now if you want to what is it, if you want to apply the back propagation or any calculation, okay, so we have to operate node by node, then we need this flatten list. Okay, this flatten list. Okay, how do you get? So this way, okay, not exactly this one, but this way the Pytorch. Okay, this way the Pytorch is working. Okay, so to understand, okay, to understand that logic, okay, first we will take a one simple example. Okay, this example, okay, this is the nested, completely nested list. Okay, so in this nested list, how we are going to make a flattened list. Okay, flattened list. This is a simple logic. Okay, so first we will define a function. Okay, in this function, so first we will define a list. Okay, this list is going to, this list is going to capture all the output result. Okay, all the output result. Okay, what will we do to get all the flattened value? First we have to, first in the nested list, first we will do a, what I say, a for loop. Okay, for loop for all the, first we will simply do a for loop. So if you do a for loop, okay, what we will get? Okay, in the first for loop, okay, first for loop we will get the this one two. First for loop have only, so if you do a for loop, you will get object 1. Okay, this is the object 1, this is the object 2. So in the first iteration you will get this object. Okay, second iteration you will get this object, third iteration you will get this object. Okay, third iteration you will get this object. In your fourth iteration you will get this object. Okay, this object. Okay, in your fifth iteration you will get this object. Okay, in our fifth iteration this object. Okay, so after getting this object, okay, after getting this object we will check. Okay, we will check whether the element is a list. Okay, whether the element is list means we will use the same flatter. Okay, you will see we will use the same, okay, the flattened nested list. Okay, we will use the same flattened nested list. Okay, so what we'll do, so flat decision list. Okay, here again this child object, this object. So if you see the object, first object, where will it come? The first object is not a list. Okay, first object is not a list, so the code will not run this part. Okay, code will not run this part, it directly comes here and directly we will get the result appended to the element. Okay, so first in our first iteration we will get the only one element, that is a only one. Okay, so on the next iteration we will get this list. Okay, this list, in this list, okay, in this list, this is the instance of list. Okay, this is the instance of list, so this line will become true. Okay, then it will call the same function again. Okay, next it will call the same function again. So in this function, what will happen in this function? In this function same. Okay, this function again come this point. Okay, again this for loop. In this for loop, okay, here this is the, what I say, this is the first element. Okay, this is the first element for the first iteration, second item. Okay, first iteration, second item. Now in a second call, okay, second call of this flatten nested list. Okay, so this is the first element here. First element here means automatically this element move to the result. Okay, this element move to the result. Okay, then it will check the 3 and 4. Okay, 3 and 4. Here what will happen? So again this is the list. Okay, then again it is called the first time it's called this one. Okay, this is the first call, this is the second call. Okay, this is the second call. Okay, this is the second call. So then again it will come to the second call, but these all these two elements are not a list. Okay, not a list. Then automatically we will add already one. We have 1 and 2 and again 3 again 4. Okay, so now we will have the 1 2 3 4. Okay, this is the in this step. Okay, object 2. Okay, in object 3 we will get object 6, we will get the object 6 because object 6 is the first is object 6 is the not a list. Okay, then the control comes here, so automatically we will get result upon the 6. Okay, next we will get the object 4. Okay, in this object 4 we will, okay, what will happen? Okay, so we will again we'll go into the iteration of all these things. Again first we'll get 7 and 7, then 8 and 9 will go, then we will get the 8 and 9, then finally we'll get the 10. So this way the final result will be a flattened one. Okay, so if you see, okay, if you see a flow diagram. Okay, if you see a flow diagram, so this way. Okay, you see this is the simple its logic. Okay, transfers through each element. Okay, transfers to each element. First it will check it's a element is a list. Okay, first it will check the element is a list. Okay, yes, if the element is list means again it will go to the, okay, it will go to the recursively flatten the list. Okay, same function, it will call the same function, again it will go to the list, then it will check. So if it is no, then it will add element to the result. Okay, so then again, so in the for loop is rotated, all this entire thing. Okay, transfers through each element. Okay, transfers through each element. Okay, okay, this way the for loop is rotating here, transfers through in the each element. Okay, so here the for loop. Okay, so again and again we will get to, so finally we will get the result way. So this way the nested object into a flattened object, this way we are getting a nested object to flatten object. Okay, so first we will just run this program. Wow. You will see, so this is our original nested list. Okay, this is our original nested list. Okay, so this is our flattened nested list, our result. Okay, 1 2 3 4 5 6 7 8 9 10. Okay, so if you want to, okay, so if you want to give some print statement here, you can get what will happen step by step, you will know. Okay, so okay, okay, print element added element. Okay, element. Okay, okay, called okay, if I call this, okay, first element added 1, already we have seen all this sequence, already element added 1, next nested called again. Okay, 2 3 4, then the element added 2, then nested called again 3 comma 4, element added 3, element added 4, element added 5, then element added 6. Okay, because element added 6 is the individual one as the last one. Okay, so then finally again nested called, then element added 7, then nested called, because whenever this the element is a list, okay, nested called again. Okay, again the nested called. So this way this, okay, flat and nested logic, so running the, so this logic. Okay, thank you for watching this video, so we will see in our next video. Thank you very much.